All right, everyone. So in this video, we're going to go through your notes about rate of solvation. So up until this point, we've talked about several things. So we've talked about how you have solutions, right? And a solution is made up of a solute and a solvent, and how your solute can be either ionic or covalent. And your solvent, the thing that's doing the solving, is most of the time water, right? We talked about how ionic compounds, when they try to dissolve to create the solution, they do it through solvation and dissociation, right, as their process. But covalent compounds are solvation only. And then in our last lesson, we learned how to measure the strength of our solution and the concentration through molarity and percent by mass. In this video, we're going to talk about not necessarily how it dissolves, because solvation and dissociation, that's the how, like the process. What we're going to talk about is the speed or the rate that happens and how we can change the speed that it dissolves. So as a reminder, solvation is only going to occur when the solute and the solvent particles actually collide or touch. Okay, if your water is not touching your sugar, it can't dissolve the sugar. Okay, it's just basic kind of common sense. And so there are three common ways to increase the number of collisions between those particles. And when you do that, it will increase the rate or speed that the solute will dissolve. So the first way that you can increase the number of collisions and increase the speed is by increasing the agitation. So when we talk about agitation, we mean stirring or shaking. So like if you are adding something to water, like in a water bottle, if you shake it up, it will help dissolve it faster because it increases the collision frequency. You're forcing your water and whatever it is you're trying to dissolve to touch and collide. You can also increase the surface area. The way you increase the surface area is by breaking it into small pieces. So when you have small pieces, they're going to allow more collisions to occur. So small pieces dissolve faster than big pieces. This is something that we know just from our own experiences. And then the other thing you can do is you can increase the temperature of our solute. Okay, when you increase the temperature, it speeds up the movement, okay, which increases the frequency. If you start running down the hallway, the likelihood that you're going to collide with someone else, it increases by a lot, okay? So things at a high temperature move fast. So if we have a hot temperature, that means the particles are going to move fast. Whereas if you have a low temperature, then they're going to move slower. So let's dive into temperature a little more, because temperature is unique in the fact that it's going to affect solid and gaseous solutes differently. So solubility, or the amount that you can dissolve, is affected by raising the temperature. So temperature affects how quickly it dissolves, but also how much of it dissolves. And that's because of the kinetic energy. So remember, kinetic energy from physical science is referring to the energy of movement. And so when the kinetic energy of the particles increases, this causes more collisions between particles to occur than at a low temperature, okay? And if you're one of my honor students, I've mentioned the word collisions a lot right now, and your lab is over rate. So in your lab report, you should be discussing collisions, just as a reminder. But temperature is going to affect solids and gases differently. So if we look at both of these, so solid and gas, there are solutes, they're what we're trying to dissolve. So let's look at an example of maybe sugar for our solid. So we know that if I increase the temperature, right, this is going to dissolve faster and more of it at a high temperature, right? We know that if we increase the temperature of our water, we can dissolve sugar a lot faster than at a cold temperature, okay? But a gas solute is not always the same. So if you think about when you've ever had a gas dissolved in a liquid, think about a carbonated beverage. So, sorry about that. So if you think of a soda or a carbonated water, anything that's carbonated is going to have carbon dioxide gas in it. And carbon dioxide gas is actually going to dissolve. And guys, when we say the gas is dissolved, we mean that the gas is in the liquid, okay? And it's going to dissolve faster and more at low temperatures, okay? So let's think about what's actually happening when you open a soda, okay? So if you have a soda can, right? So let's say we have our soda, okay? And you have water. And so you have water in your soda. I'm going to make this a little bigger so I can, okay, so let's say you have water. What happens is you have these carbon dioxide molecules in there, okay? And when you open your can, those molecules rush to the surface because they don't want to be dissolved. Remember, carbon dioxide is non-polar, but water is polar. So these things are not supposed to mix. You have to force them to stay together. So carbon dioxide is going to try to escape the water. It doesn't want to be there. And when it breaks the surface, it creates the bubbles that we so enjoy in our soda. Okay, well, if you have a high temperature, remember, at a high temperature, things move fast. Okay, so that means the carbon dioxide will be able to move fast to the surface, and it will create the bubbles more frequently, and that will be undissolved. So when the CO2 is in the water, it's dissolved, but when it's out of the water and it's now escaped into the air, then we know it's not dissolved anymore. So if you have a cold temperature, then it can't escape the soda as easily. So if you want to keep your soda bubbly for a longer period of time, you can make it cold, okay? One thing to keep in mind, by the way, with sodas, they are mentioned a lot in the gateway sometimes. And whenever we refer to sodas, if we say a soda is flat, okay, it's a very English American type way of describing the soda. You might say that the soda's gone bad. What we mean is that there's no bubbles left in the soda, okay? And so I want everyone to be aware of that. That's what it means when someone says the soda is flat, okay? So we know, though, that when we buy a soda, it's not always cold, right? So how do the manufacturers get the soda from their plant to us if it doesn't stay cold, right? When I buy sodas at the grocery store, they're normally just in the aisle and they're not refrigerated. So what they do is they use pressure. Pressure is only going to affect the solubility of gases. And this is because increasing the pressure of a gas solution pushes the particles together. It's kind of like if you're at the pool, right? And you're like, your brother or your sister kind of dunk you in the water and you try to come back up and then they dunk you again. Pressure is kind of like pushing the gas to stay inside the water. And this means that there are going to be more particles per volume. So it's going to be a very high concentration of carbon dioxide. They're going to put a lot more carbon dioxide in your can of soda than you really need. That way it will stay that way, okay? And then they put a lid on it so that the pressure remains constant. And so one thing that they've sometimes asked you to do on the gateway is to actually write down what's the chemistry, what are the steps behind creating a carbonated drink or a soda. And so a soda solution is going to have three, and I'm simplifying this, three main parts. You're going to have your solvent, and then you typically have a solid solute, and you have a gaseous solute, okay? And so your gas is carbon dioxide. That's what gives the bubbles. Your solid is sugar. You also have some sort of flavoring, and you have maybe syrups or other liquid solutes. And then our solvent is almost always water. Now, because in order to keep a gas dissolved, you have to put pressure, right? That's going to be your last step. The first thing you're going to want to dissolve is sugar. So when we're writing out our steps, we would want to heat up the water, right, to dissolve the sugar, because sugar, which is a solid, dissolves faster at a high temperature. But if we now want to add the gas, we can lower the temperature of the water and the sugar will remain dissolved, and that will make it easier to dissolve or add the carbon dioxide. So we're going to cool down the solution, because it's not just water anymore, it's a sugar water solution. So we cool down the solution to dissolve the carbon dioxide gas. And then once we do that, we increase the pressure and add a lid. Okay, if you don't have the pressure, then even with a lid, it's not going to keep all of your bubbles inside the solution. So we increase the pressure, and seal it with a lid. Okay, and that's how we create a soda. So those are kind of the basic steps for how we affect rate of solutions.